we're going to get back to solving equations again. And this time they're going to have fractional coefficients, meaning they have a fraction as one of the numbers in front of a variable, right? They have a fraction in the problem. So, I know you know how to solve equations, okay? So our goal, our objective, solve equations containing fractions, i.e. rational numbers, rational expressions. Okay, now, we actually have sort of done this before. Okay? Let me choose some problems so you can refer to them if need be. Let's say I have you, we're just sort of jumping into it, because we're solving equations. If they're equal, you can do anything to both sides that you'd like to. You can add to both sides, subtract to both sides, multiply to both sides, divide, because they're equal. They're equations. So all those properties of equality back in chapter 1, 2, they come into play. So problem number 2 says 3u divided by 5 minus 5/6 equals u over 10. And you have a choice. You can either combine like terms on the left side by finding a common denominator and then cross multiplying for a proportion, or you can decide right at the beginning, since these fractions are equal, whatever I do to one side, I can do to the other side. So if you don't like a fraction, choose a number that will reduce with all the fractions. In other words, choose a common denominator. So we are going to multiply by the least common denominator of each term. Terms are separated by plus or minus. So I have 2 terms on the left, 1 term on the right. So in this case, a common denominator that 5 goes into, a multiple that 6 goes into, and a multiple that 10 goes into. That common denominator would be the number 30. And then because you are in control and the multiplication property of equality says whatever you choose to multiply the left side by, you better do the same to the right side of an equation to keep them equal. And then I'm going to take the time to write it out in our first example here. Since there's 2 terms on the left, I need to distribute the 30 to both terms. Since there's only 1 term on the right, I only need to distribute it to that 1 term. And now reduce, because you're guaranteed they will all go into them because it was a multiple. 5 reduces with 30, so I'm left with 6 times 3u. 6 reduces with 30, so I'm left with 5 times 5. 10 reduces with 30, so I'm left with 3 times u. And then from here, it's a linear equation. I'm going to move the 25 to the right side. At the same time, I'm going to subtract 3 u's, divide by 15, reduce by a common factor of 5, and we should get u equals 5/3. Okay. So I'm going to, let's try number 18. I am going to change the variable to an x, though, instead of a t. So 2x times 3x plus 1, all of that divided by 5, minus x plus 1 over 2 equals 1 over 10. And you'll notice all the denominators are numbers. That's good because we remember that we can never divide by 0, and since we don't have 0 in the denominator, we're okay. So in this case, you may see what number we want to multiply both sides by to cancel with each of the fractions. So I'm going to choose to find their least common denominator. In this case is the number 10. So I'm going to choose to multiply every term on the left side by the number 10. Whatever you do to one, you do to all, and it keeps it balanced. Now you're guaranteed they will all reduce. 5 reduces with 10, so I'm left with 2 times 2x times 3x plus 1. 2 reduces with 10. 5 times x plus 1. And, oh, this is lovely. These are reciprocals of each other, so I'm left with the identity of 1. 10 reduces with 10. And now the rest is chapter 4. I can multiply in any order. I'm going to choose to say 2 times 2x is 4x. Distribute my 5. Distribute. And now I notice it's quadratic. Its degree is 2. I'm guaranteed 2 answers. In order to have 2 answers, I'm going to have to factor and solve from here. So if I combine like terms, I get a 12x squared. 4x minus 5x is negative x. Bring the 1 to the other side, I get a negative 6. And again, you have factored. So depending on what method you like, I'm going to say factors of negative 72 that add up to negative 1, negative 9, and 8. So it's guaranteed to factor. Whether you choose to use grouping is fine. If you like factoring using a Punnett square, fine. If you like factor using kind of that FOIL method, fine. When you find your factors, I need a 9 and an 8. So I'm going to choose my first factor to be a 3 and a 4. That way, my outside term of FOIL, I'll make negative 9. My inside term of FOIL, I'm going to create positive 8. And then based on what we did in chapter 4, the only way we can multiply and get 0 for an answer is if either the first number represented by 3x plus 2 is 0, or the second number represented by 4x minus 3 is 0. Subtract 2 divided by 3, add 3 divided by 4. So I end up with 2 solutions. I'm going to list them from least to greatest, from left to right. And you should get negative 2/3 or positive 3/4. So if we don't want the fraction in the equality, in the equation, we can use use the multiplication property of equality. So what do you do if it's an inequality? Well, we're going to use the multiplication property of inequalities. So let's say I give you, trying to see, here's number 8. X minus 5 divided by 9 is less than or equal to 2x over 15 minus 2 over 5. Well, we have properties of inequalities which follow the same guidelines as equalities. Whatever you do to one side, we do to the other side. So I'm going to find a common denominator first. That common denominator has to have a 9. So 9 has to go into it. So 3 times 3 has to go into it. 15 has to go into it. So 3 times 5. I already have a 3, don't have a 5. And then 5 has to go into it. It's already there. So it looks like our common denominator in this case is the number 45. So I'm going to choose to multiply both sides by 45. You don't have to use the least common denominator. You just need a common denominator. So if you prefer, you could have used 9 times 15 times 5. That would have also worked. They all would have reduced. You would have ended up with the exact same answer. Your numbers might have been a little larger to begin with. Doesn't matter. So if you don't like finding the least common denominator, just find a common denominator. 9 times 15 times 5. Okay. I chose least common. 9 goes into 45 5 times. That's going to give me 5 times x minus 5. When I distribute, 15 goes into 45 3 times, so I'd be left with 3 times 2x. 5 goes into 45 9 times, I'd be left with 2 times 9. Now do the multiplication. Distribute. Excuse me. 2 times 9 is 8. The degree is only 1. The highest exponent is only 1, so I'm only guaranteed one answer. I'm going to choose, let's see, if I bring the x's to the left by subtracting 6x. I take the 25 to the right by adding 25. Now remember, when you divide, that's going to change the sign, which means it changes the symbol and it changes the sign. So my solution is x is greater than or equal to -7, or it's the set of all x values such that x is greater or equal to -7. Same thing, the set of all x values such that, that's what that line means, x has to be greater or equal to -7. Okay? And then if you end up with a degree higher than 1, like x squared, you would do what we did in chapter 4, and we would use the sign test. Sign test. So I'm going to remind you of that, and when you get to problems such as 23, 24, you may have to use the sign test. Okay, so that's it. If you have a fraction in the equality, make sure the denominator's not 0. Cancel out the denominators.